right, here we go. All right, so guys, before we start solving using the substitution method, can we please remember that no matter how you solve a system, whether it's by graphing or the substitution method that we're about to learn, or the third method that I haven't shown you, no matter how you solve it, there are only 3 kinds of answers. We saw them yesterday. Can somebody name one kind of answer that you might get? IMS. Yesterday we saw that IMS happens when they ended up being the exact same line. And they have every single point in common, so there's infinitely many solutions. What was another answer you might get? No solution because they're parallel. So no solution. Maybe there is no x and no y value that will make both equations true. Yep. And then one solution. That's what you're probably going to get 98% of the time. There is one x value and one y value that satisfy both equations. Now yesterday, since we were solving by graphing, it was that point, right? So a lot of times you had your answer and it was written as an ordered pair because it was the point they met at. Even though we're not solving by graphing, they a lot of times still have you write your answer as an ordered pair. Okay, so the first method was to solve it by graphing. Check, we learned that, we saw it yesterday. I don't spend another day on it because I don't think anybody's gonna choose it as their go-to method in the future. Method 2 is the substitution method. In order to use the substitution method, you need to know what one of the variables is equal to. That is what the entire method is based on. We either need to know that x is equal to something, so we can substitute it in, or we need to know that y is equal to something, so that we can substitute it in. Okay. Well, guys, I wrote down a list of steps for you guys to follow if you ever get lost while you're at home. I don't want to read them right now. They won't make any sense. Let's jump down to example 1, and you'll see how the steps show us what to do. Okay. So here's example 1. It says solve the following systems using the substitution method. So they've given you 2 equations that have 2 variables in them. Now remember, the x value that is missing in this equation is the same x value from the second equation. They represent the same missing number. This y value is the same y value in the second equation. It's the same missing number. We're trying to find out what number or numbers can you plug in for x and y that make both equations true. All right, well, guys, in order to use the substitution method, we need to know who x is equal to or who y is equal to. Does either one of these equations tell you one of the variables is equal to? Yeah, the second one. So, guys, this is pristine set up for the substitution method. If they're going to flat out tell you, hey, x is equal to that, then take that and plug it in for x in the other equation. Substitute it in. So we're going to right away go right to the substitution. Take who x is equal to and plug it in for the x in the other equation. So let's start rewriting this equation. Instead of 6 times x, it's going to be 6 times who is x equal to? Negative y minus 9. Beautiful. And then continue. Minus 5y equals 1. So by substituting that in, it left you with a new equation, but this equation only has one variable in it. So now we're going to be able to solve this for y. So everybody distribute, combine your like terms, and solve that for y. Get me a y value. Just be careful because, guys, the one thing about the substitution method, it's a little long and it leaves a lot of room to make silly mistakes. So watch your signs. All right, look up when you find out who y is so I know you're good, and make sure you got the same answer as me. Okay. Okay, did we get negative 5? All right, now remember, it's a system. There are 2 unknown numbers missing from this problem. We just found one of them. And you will always work the hardest for the first answer. So now we have our first answer, but now we got to figure out x. So we're going to do more substitution. So now you're going to take the number that you just found out y is, and you're going to substitute it in here and solve for x, or you're going to substitute it in there and solve for x. Now, if you're asking me, guys, this equation is beautifully set up for who x is going to be. It's a choice, though. You can plug it into either one. I'm choosing this one because it's definitely easier. So I'm going to take this equation and this y value, and I'm going to substitute the -5 in. Go ahead, Derek.
You still put -5 in, positive.
So now x will equal, there is a negative sign already. Then you're plugging in a -5. So it's definitely a double negative situation, and it's going to turn to a positive. And then what's 5 minus 9? -4. So now in order to make both equations true, x has to be a -4 and y has to be a -5. Now guys, we did not solve this by graphing, but we could have. It means if you graphed it, they would have met at the point -4, -5. So a lot of times, no matter what method you use, they still have you write your answer as an ordered pair. So we're going to write our final answer as -4, -5. And on your homework, which is going to be on quizzes tonight, I know you guys, I know you like Delta Math better. I did not like Delta Math's assignment for the substitution method, so I made an assignment on quizzes, and you're going to fill in your answer as an ordered pair, no spaces. All right, I tried to give you a bunch of different scenarios, so let's look at example 2. Now guys, keep in mind, this is as easy as a substitution problem will ever get, because you knew right away what one of the variables was equal to, and you were able to start that substitution process right away. Sometimes you have to get it set up for substitution. So look at example 2. Yep. Okay. The substitution method says that you need to know who a variable is equal to. Does either one of these equations say x equals or y equals this? So we have to get it ready for substitution. So guys, you have to either pick the top equation or the bottom equation, and you have to pick one of the variables to solve for. So either solve the top equation for x or solve it for y. Solve the bottom equation for x or solve the bottom equation for y. You can literally do any 4 of those things and still be right. However, there are definitely going to be easier variables to get alone. So please, if you start getting a variable by itself and you have created a bunch of fractions, bail out. Start over, pick a different equation, pick a different variable, all right? Don't create unnecessary fractions. So guys, can everybody just look up here really quick? I'm going to do this one time, and then I won't do it again. But just humor me. If you said, you know what, Hardy? I'm going to the top equation, and I'm solving it for x. Do you agree? In order to solve this for x, you'd have to add y away, right? And then what would you have to divide away from x? Now, that means you'd have to divide this and this by 6. Are the 1 and the 2 divisible by 6? No. So that would create unnecessary fractions. So for the love of God, don't pick the first equation and solve for x. That will make it a much harder problem. All right, let's say you said, you know what, forget it, Hardy. I'm going to go to the first equation, and I'm going to get y by itself. Do you agree? You would have to minus your 6x's over, and then what would you have to divide away from the y? Is that 6 and that 2 going to divide by -1? Everything divides by -1. It's beautiful. That is a great, great choice. All right, or maybe somebody said, you know what, Hardy, I'm going to this equation, and I'm going to get x by itself. Do you agree? They would have to add y away, and then who would they have to divide everything by? 3. Is that 1 and that 19 going to divide by 3? No. So for the love of God, don't solve the bottom one for x. It'll create fractions and make it much harder. What if they said, forget it, I'll solve the bottom one for y? Do you agree they would have to minus 3x's away, and then who would they have to divide by? Is that 3 and that 19 going to divide by -1? And that's awesome. So right now, your best options is to either solve the top equation for y or the bottom equation for y. Those are, to me, your only 2 choices. Go ahead.
Would this be Let's do that.
I believe so. Mhm. Yep, well, that'd be why we're not looking for the y intercept. All right, so now I'm going to choose the top equation and I'm getting y by itself. That's what I'm gonna do. So if I do that, a couple different things I could do. You can either add y and minus the 2, or, like we normally do, minus the x's away. I like to put my variables first, doesn't matter though. And then I'm going to divide everything by -1. So I find out that y is really equal to 6x minus 2. So now I can take that value and I can substitute it in for y in the other equation. Guys, that's the biggest thing. We had to set this problem up. So please don't solve the top equation for y and then plug him into himself. You cannot do that. You have to plug it in to the other equation. So I'm going to take the fact that this is what y is equal to, and I'm going to plug it in for y in the other equation that I haven't used yet. You can't plug it in to the same equation. Go ahead, Darian.
Do you get 0 that happens?
Yeah, you'll get like a false IMS or no solution. All right, so here we go. So I'm going to take 3x. I'm going to subtract 1. So we're going to substitute this in for y. But guys, here's the thing. This problem says I have to subtract y. So you better make sure that you subtract everything that you're about to plug in for y. So how do I keep the 6x minus 2 together and make sure I subtract all of it? What do I have to use? Parentheses. You have to put it in parentheses. If you don't, you will be wrong. So guys, follow me. This is 3x subtract, this is our y. This is what y is equal to, and it equals -19. And now the equation you are left with only has an x in it. So everybody solve that for x. And you should get your first answer. Go ahead. Oh.
I got this part, but I didn't.
Okay, how did you get -6x minus 2? You would have had to minus this over, so he would have been negative, right? And then when you divide it by a negative, it goes to a positive. So that should be 6x minus 2. He should not be negative. He should have been negative when you minus him away. Okay? Yep, so distribute it. Keep going. Yep, combine your like terms. What you got? Wait, hold on. It's 6x minus 2, and you plugged in a 9. So be careful. But that's what I said. This is the one thing that I find to be annoying about substitution method is it's tedious. It's long. You can easily make a silly mistake. Look up here to see if we're getting the same process.
Didn't we already get y?
No, we didn't get y yet. We found out what y was equal to in terms of x, but we haven't gotten a physical number for him yet.
Oh my gosh.
I know, it's a process. It's not the hardest thing, it's just long. It's long.
Between this and advanced and chemistry today.
Oh no, this you're fine there. This is all solving and combining like terms. And did everybody get 7? Did you find out x was 7? Okay, but like I said, he's only half the answer. We need 2 variables, but the first one is the hardest one to get. So now that you know who x is, now you have to substitute again. So you're either going to take 7, substitute it in for that x, and solve for y. Or you're going to take 7, substitute it in for this x, and solve for y. Or even better, the third option, you have this equation that you made. You can take 7 and plug it in for that x and solve for y. And this equation is already ready and set up for what y is meant to equal. So I'm going to plug it in here. I could have went there. This one's easier. Go ahead, Darian. So now I'm going to plug 7 in for x. So y will be equal to 6 times, not x, 7, and then minus 2. And then we're just PEMDASing. Multiply first. And then what's 42 minus 2? 40. So y must have been 40. So guys, that means if we had to solve this by graphing, we would have been graphing until we got to a y coordinate of 40. Thank God we didn't have to solve this by graphing. So now we're going to write our answer as an ordered pair, x comma y, 7 comma 40. That means x has to be 7 and y has to be 40 in order to make both of those equations true. So that one, guys, I feel like that's as hard as these problems are ever going to get. Because first you're going to have to pick an equation and pick a variable to solve for. Then you're going to sub it in, get your first answer. Then you take your first answer, sub it in to get your second answer. So that is a process. All right, another scenario is, look at number 3. Number 3 is meant to be like a quick hitter, like a quick problem. But man, it always throws you guys for a loop when they write it like this. And it's meant to be one of the easier ones. Okay. So look at this one. We need to know what one of the variables is equal to, either y equals or x equals. Does this problem tell you one variable? Yeah, it actually tells you 2, right? The first equation says, hey, y equals 5x minus 2. The second equation says y equals 1/2 x minus 2. So guys, remember, the y that is in this equation represents the same y, the same missing number in the second equation. So if this y ended up equaling 10, what does this y have to end up equaling? 10. So this y is the same thing as that y. They represent the same number. So guys, think about it. If they say that y has to equal that, and then they say the same y has to equal this, well then what do those two expressions have to be to each other? The same. They have to be equal. So all you have to do is set those expressions equal to one another, and you're left with one equation to solve. So all you have to say is 5x minus 2 better end up equaling the same thing as 1/2 x minus 2. Just set them equal because they represent the same thing. And now we're left to solve. Now guys, I don't want to solve with a fraction. You can if you want to. I'm going to get rid of the fraction. Who's the only denominator that you see right now? 2. So who's the smallest number that a 2 can become? 2. So multiply your tops by 2. And to me, it makes it really easy to solve. So I'll get 10x minus 4 equals, now look here, 2 times 1 is 2, divided by 2 is 1. 1x is really just x. And then minus 4. Okay, so get x's to one side, numbers to the other, and let me know who x is.
You have to subtract the x's, not the 8%.
Yeah, you got to move them from one side. So either minus your 10x's or minus your 1x. Doesn't matter which one. But yes, if you move from one side of the equal sign to the other, you have to use the opposite operation. Now guys, something should happen. Is anybody getting a 0?
Yeah.
Beautiful. But can everybody look up here? Does everybody understand that the x's are still in the problem, right? Not the variables went away. There's still a variable, which means keep solving. There is still a variable, keep solving. So I'll divide by 9, and who does x end up equaling? 0, which is perfectly fine. But guys, I have to say it again. The variable didn't cancel out. The numbers did, but the variable was still there. So as long as there's a variable, keep solving. All right, now, if x is 0, then substitute it in to one of the originals and find y. I'll go back to the top one. So then y equals 5 times 0 minus 2. Guys, what's 0 minus 2? Negative 2. So that means they would have met at the point when x is 0 and y is negative 2. Okay, I have shown you every single kind of problem that you're going to see on your homework or anywhere for that matter. However, we have not seen a no solution or an IMS. So when we were graphing, we got no solution by finding out they were parallel lines, right? Well, we're not graphing, so you're not going to know they're parallel lines. So how are you going to get a no solution by the substitution method? And then we got IMS by finding out they were the exact same line. But we're not graphing, so you're not going to find out that they're the exact same line. So how are you going to get IMS? Here's how. If you get IMS, or no solution, it's because when you are solving, the variables cancel out. The variables literally disappear. And you will either be left with a true statement, like 10 equals 10, or -4 equals -4. And if you are left with a true statement, guys, true is good. True means lots of answers. That means IMS. If you are solving and the variables cancel out and you are left with a false statement, like 8 equals 12 or -5 equals 21, that is bad. That is no solution. So guys, look at number 4. Let me show you, and then I'm going to have to stop, but let me show you how this is going to play out. Do we know who X or Y is equal to? I have 5 minutes. I'm good. No. Tell me right now, top or bottom equation, X or Y. Who are you getting by itself? In the top equation, because he's going to be the easiest one to get alone. Guys, if you have a variable with a 1 or a -1 in front of him, please do that one. Everything divides by 1 or -1. All right, so let's get X by itself. Super easy to do that. All right, just minus your Y's away. And you are left with that. Double check. Now that you know who X is equal to, sub it in for X in the other equation that we haven't used yet. So take this right here, plug it in for X in the other equation, and watch what's about to happen. 2 times not X, plug this in, that's who X is equal to. Okay? Normal, let's solve for Y, so distribute. When you start solving for Y, combine like terms, but what happens to them? What happens to a -4Y and a +4Y? They cancel out. There are literally no more Y's left in this problem. Now it comes down to what statement is left. +6 equals +6. Is that true? That's a good thing. True is good. True means lots of answers. So what's your answer going to be? IMS. That is how an IMS or a no solution is going to come out. It means, had we graphed, they would have been the same lines. So guys, just pretend, for giggles, if this ended up being 6, and this was like 8, does 6 equal 8? That would be a no solution, which is what number 5 ends up being. So if you try number 5, you should see the variables cancel out, and you are left with a false statement. Okay? All right, you guys do have homework tonight. It's on quizzes. It is due tomorrow at 11:45 at night.